Hey everybody, how's it going? I'm Corey. Thanks for joining me. And I go by Corey JA on the internet. And today we're gonna do some Advent of Code. We are on day 6. So let's jump right into it. Day 6. Wait for it. The ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and the small island where the ferry has docked. As you try to figure out what to do next, you notice a poster on the wall near the ferry dock. Boat races open to the public. Grand prize is an all-expense-paid trip to Desert Island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. As part of signing up, you get a sheet of paper, your puzzle input, that lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and boats don't move until the button is released. Okay, so for example, we might get 3 times 7, 15, 30, and 3 distances, 9, 40, and 200. This document describes 3 races. The first race lasts 7 milliseconds. The record distance for this race is 9 millimeters. The second race lasts 15 milliseconds, and the record distance is 40 millimeters. And the third race lasts 30 milliseconds, and the record distance in this race is 20 millimeters. Your toy boat has a starting speed of 0 millimeters per second. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per millisecond. So because the first race lasts 7 milliseconds, you only have a few options. Don't hold the button down at all, that is, hold it down for 0 milliseconds at the start of the race. The boat won't move, it will have traveled 0 millimeters by the end of the race. Hold the button for 1 millisecond at the start of the race. Then the boat will travel at a speed of 1 millimeter per millisecond for 6 milliseconds, reaching a total distance traveled of 6 millimeters. Hold the button for 2 milliseconds, giving the boat a speed of 2 millimeters per second, and it will get 10 millimeters to move, reaching 10. Hold the button for 3 milliseconds, and for its remaining 4 milliseconds, it'll go 12. And then 4 is the reverse. If you hold the button down for 4 milliseconds, it only has 3 milliseconds, so you still end up at 12. And if you hold the button down for 5 milliseconds, it causing the boat to travel 10 millimeters. 6 milliseconds, 6 millimeters, and 7 milliseconds is the entire duration. Phew! Since the current record for this race is 9 millimeters, there are actually 4 different ways you could win. You could hold down the button for 2, 3, 4, or 5 milliseconds at the start of the race. In the second race, you could hold the button for at least 4 milliseconds and at most 11 milliseconds to beat the record, a total of 8 different ways to win. In the third race, you could hold the button for at least 11 milliseconds and no more than 19 milliseconds and still beat the record, a total of 9 ways you could win. To see how much margin of error you have, determine the number of ways you can beat the record in each race. In this example, if you multiply those values together, you get 288. 4 times 8 times 9. Determine the number of ways you could beat the record in each race. What do you get if you multiply those numbers together? Okay. So the parsing should be pretty easy here, right? We just have some races to parse. It's a little annoying that each line is like times all on one line and distances all on another line instead of having the races on the same line, but like it's fine. We'll just collapse them all together. Just a little silly. And yeah, let's just start with parsing and then we're gonna think of it. I think for part 1 we can just do the naive thing, and just like enumerate all the options and find out ones that work. But we will see if how we're feeling after that. Okay, so we have a rebuild that we've been using for all of these advent of code puzzles. So let's get a new cargo binary created. I keep not mentioning this at the very start of the stream, but we are doing Rust today like we've been doing for all of these challenges so far. So I've just been naming my crates after the number and title of the puzzle. So this one is 6, wait for it. And then we have to add that to the workspace. What is a robot? No, not quite. It's wait for it. So now we can cd into this day 6 package and cargo run. Awesome. We get the hello world and we are off to the races. So the first thing that we'll do is we'll just set up some of our structure here. We'll make an input part1 function that takes a string, and this is going to return like a U64. We'll mark that as to do. And we'll do let sample input is including the string, which we don't have in the code base yet. We'll add that in a second. Sample part1 answer is that. Debug our sample part1 answer. Awesome. So now let's grab our sample input. That's just this. New file, sample input. Okay. That now exists. Yay! Okay, so now we can start parsing. So let's see, we have 2 lines here. We have times and distances, so let lines equals input.lines collection to a vec. Let times equal lines at 0. And let distances equal lines at 1. Let times equal times dot a strip prefix of, and I think it's time, like that. Time. We're gonna leave the spaces off. We know the prefix is gonna be there, and we'll trim the white space because might as well. Thank you, Copilot. And we're gonna do the same for distances. Distances. I think it's just distance. Okay, so then let times split white space, map them all to U64s. Let distances, and then I want to zip them together. So let, what are these? Records? Races? They're races. Times dot into iter. Zip the other one collect to a vec. And actually, so let's stop collecting these to vectors and leave them as iterators, so that we can zip them without needing to call into iter because they already are iters. And then races, yeah, we get a vec of tuples. And actually, what we're gonna do is let's make a struct for our input, for lack of a better name, and it's gonna have some races, which is gonna be a vec of race. We're just gonna make some structures here quick. So let's make our race structure. It has a time and a record distance, I think is the best way to put that. Record distance. And we're gonna implement parse on these. So input function parse from an input string to a self. And we're gonna put most of this in there. Sorry about that. Okay. So we're parsing our input, which has some races. So we have races as a tuple, and we're collecting to a vec. But before we collect to a vec, let's actually map it. And we will take our tuple of time and record distance, and we will create a race from time and record distance. Oh yeah, I forgot the pipe there. There we go. So now races is a vec of race, and this can just be input at races. Perfect. So now parsing is done. There wasn't really much. Yeah, we can't really parse a race independently, so that's why there isn't a parse for that. Yeah, that makes sense. I was just seeing if I could break it down more, and I think this is perfect. So now let's just say let our input is parsing our input. Perfect. So now we have to like think about this. I guess for each thing, I can return like the range that's possible. I realized in the last time that everyone was using ranges and I didn't use ranges, so I had a different solution than a lot of people on the internet, but that reminded me of ranges, so let's do that. Let's say that for each race, I want to implement, sorry, I'm just thinking and typing and not doing a good job. Possible win range, right? So we want to have a method that operates on this race only and returns a range. And actually, alias is this. Okay, yeah. Range full, range bounds, range inclusive, range 2. Interesting. I'm just not sure which one of these I want. Consider importing one of these items. Or just make it just range. Import range, yeah. Ops range, yeah. I just wanted the simple one. Okay, so possible win range is so I think what I want to do is just like go from 0 until time. Like I think I just want to say when. How do I want to do this? So okay, so let's just start looping a little bit. So for I in 0, no, I guess 0 is just not even worth it, and we'll go all the way to time. And no, we don't want to do it in reverse. We'll do it forward. Open let. So what I was thinking is that I could do something like this. Sure, we can delete the parentheses. This is just not what I want. So so we have to see if it's possible. So now we do the math, right? So for I is the amount of time that the thing has been held down. So I is our velocity. So let's let velocity equals I. And then let's let time left equals time minus I. Perfect. So then let distance, if distance is greater than, does it say greater than or equal to or greater than? I think I have to win. Go farther. Yeah. So if distance is greater than record distance, if the minimum is none, set it, and then we just keep setting max each time as we keep looping. Perfect. Copilot just kind of did that for me. Love that. So then range is start to end, and we just unwrap those values because we assume that by making it through, we have a min and a max. Missing generics for this. Oh yeah, what is this? U64. Perfect. Awesome. So now we have our possible win range, and I think we just actually want to count how big that range is. Okay, so like input dot races dot iter. Wow. That's pretty close to what I wanted, but I don't want sum, and you can't get the length of a range. Okay, so we're close, but that's not what I wanted. Can I get the size of the range? No. Oh, I can get the count though, because it's an iterator, so I can just iterate over it and count. Is that the best I can do? Maybe. And then I can reduce this. So reduce takes the function and returns an option. Yep, so the function here, wait, how does the, no, I just want the docs. Reduce, you take an accumulator, and then this item. Okay. So, oh, yeah, that was easy. I just wanted to multiply them all together. And we unwrap this, and we just make it a U64. So I guess I could just return a U size if that's the type I already have. I don't think it's a big deal. Copilot really helped with getting some of those, like that reduce right. 168, that's not the right answer. The answer was supposed to be 288. Awesome. So let's debug what we actually got here. So let's do let win ranges equal, and we're gonna stop that there and collect it to a vec. So then let's debug out our win ranges and see what they get. And we just added a to-do to this again so that we could compile it. Whoa. Where did that part 1 come from? Did Copilot just make that for me? Oh, not implemented, of course. 378. 489. Oh, okay. Oh, because I did range, and I wanted, I guess, range inclusive. Because end is valid. Wait, what? Field is private. Oh, that's fair. I also could just write this as min.unwrap. Yeah, I could just write this as an actual range syntax. That's probably better. I like that. But we do want to range inclusive because I do know the max. And let's try that again. Now we get 489, 489. Perfect. Okay. We don't need to collect to that anymore, so we can go back through doing reduce. Oh, wait, can I just do that? Reduce dot unwrap. No, because it doesn't know what to do about that. That would have been really cool if that just worked, though. A and B. And we multiply them together. A times B. Oh, I have a let here. That's why it's not letting me just return it. As U64. Okay, 288. There we go. Let's get my puzzle input. Wow. That is the shortest input we've got so far. There's a really good chance. I don't know. I feel I'm a little conflicted whether I think this is gonna work or not. I think my answer is fine, but I don't think it's that exciting. And this surprised me how short this is. And oh, okay. That returned faster than I expected. I was wondering if that was going to take too long. It just seemed too small. Awesome. Okay, well that is day 6 part 1. Day 6 part 1. Awesome. Okay, so we didn't get too big of an input. It was possible to walk through the entire ranges to find the min and the max that worked. We didn't have to do any math there, but let's see what part 2 says. Part 2. As the race is about to start, you realize the piece of paper with race times and record distances you got earlier actually has very bad kerning. There's really only one race. Ignore the spaces between the numbers on each line. So for example, from before, now instead means, oh, you just get rid of all of the spaces. Now you have to figure out how many ways there are to win this single race. In this example, the race lasts for 71,530 milliseconds, and the record distance you need to beat is that many millimeters. You could hold the button down from anywhere from 14 to 71,516 milliseconds and beat the record. A total of 71,503 ways. How many ways can you beat the record in this one much longer race? Okay. Interesting. So let's see what we want to do first. I think our input's just sufficiently different here that this is going to be part 1 input is that. Oh, actually, there's just, the only thing that we need to do is this split white spaces. Okay, let's do the easy route at the moment, I think, where we're just gonna copy and paste it. We're gonna take our part 1 input. And where do I want to put it? It's sufficiently different that it feels like it could even go in a separate file, but I haven't made a separate file for any of these yet, so let's just put it here. There's no reason to think too hard about this. And there's actually only one race now. Cool. So, times and distances. There's only, yeah, okay, so we strip the prefixes, and then we say, and this is really just time and distance. Let time equals time dot replace all the spaces with nothing. And let replace just returns a string. Yeah, awesome. Let distance equal distance dot replace them. Okay, perfect. And actually, let's do dot parse. Let's just parse it right there into a U64. Perfect. Perfect. Okay. So now I have the single time and distance. Oh, so now I can just make a race. Record distance. Let race equals race of time and record distance. Self of race. Perfect. Oh yeah, single character replacement. So it wants me to use a character instead. And is there like a time dot remove all R matches? Nah, let's just leave it with the replace because I know that is gonna work. Awesome. Okay, so part 2 input, we just have a single race. So like function part 2 input as a string goes to a U64 again. Let input equals part 2 input parse input, and then input dot race dot possible win range dot count. I don't actually know if I think this is gonna go great. Part 2 sample debug out our part 2 answer, sample part 2 answer. Perfect. Okay, that wasn't too long. 71,503. Yep. But I feel like there's no way, right? My input, my part 2, my part 2. That wasn't even that long at all, and that was in debug mode. I'm gonna say that doesn't really need an optimization then, I guess, right? That's the right answer. You got 1 gold star. Closer to restoring snow operations. That'll do it for day 6 of Advent of Code. Yeah, because I can even run this in release mode, and it finishes basically instantly. Yeah, okay. Well, I guess we'll take that then. Day 6, part 2. Let's take a look at that one again and just go over the puzzle one more time. Let's go back to day 6. Yeah, so in the first part, we had multiple races. And we had to, what's actually really interesting is that like I didn't need any optimizations. It just was fast enough. But this really seems like one where they expected you to need you to optimize, because part 2 was like simpler for me than part 1. And that's pretty interesting. It's really interesting to me that I didn't have to do anything. I guess probably because I'm using ranges here, and when I go to count the range, I bet this gets optimized just to, like, you know, I doubt I actually have to go through the entire iter here to count it. Though this is using iter behavior and I'm calling count, so it's kind of funny that it's just so fast, but I wouldn't be surprised if this is actually not going through the range and iterating all the way down. I bet this is doing something a bit smarter than that. just because it's so fast. I didn't have to do any optimizing, so I bet it's slightly optimized under the hood, which is nice. But yeah, okay, let me do an actual summary since I got distracted there. So the idea was that there were multiple races. This was the time, and this is the distance for each race, so they're more vertically aligned this time. So this first race was 7 milliseconds, and I needed to beat 9 milliseconds. And you gained velocity by waiting before the race started and pushing a button. So for every turn you waited, it increased your velocity. So what we ended up doing is for each race, we parsed down to the race, which was the time and the record distance. And for each race, we needed to find the min and the max of the win range. So like how long we could hold the button, how long we had to hold the button up to the maximum time we could hold the button, the minimum time and the maximum time we could hold the button for and still beat the distance. And we basically just did that by trying them all, right? We do the math, we find the velocity, we find how much time was left, we find what the distance would be by multiplying them together. And if the distance was greater than the record, we recorded it. And if this was the first time, if this was the first thing we'd seen, first time we'd seen something, we knew it was the minimum, so we marked it. And then we kept marking the max as we got higher and higher. And eventually we'd find the max by the, the one where we didn't have a record distance. And we know we can win each of these, so we can unwrap these here pretty safely. What does your counting code look like? Yeah, sorry, I didn't see your thing before. But yeah, range has its own implementation for count rather than relying on the trait's default implementation. Awesome. Yeah, that's what I had to assume, because it didn't seem like it was actually going through the iterator and counting, right? That would have been slow. And I have to imagine that was kind of the optimization that Advent of Code was pushing for in part 2. I just got it for free because I was using count on the range the whole time. And thank you for stopping by, Nathaniel Bumbo. Sorry I missed your first message, but we're just going and looking through the solution real quick before wrapping up. This one wasn't super duper challenging, though it definitely helps when Rust had my back. So yeah, that's how we found the possible win range. And then, like I was just saying in chat, we just counted that range, which is not just actually counting the iterator, which is great. It's implemented specially and just is likely going to do max minus min. And then I guess figure out the one offset. It would be max minus min plus 1 because I'm inclusive, I think. But I didn't have to implement that. Oh, it's right here. Cool. That's cool. I could just click right to it. Is this on range? It has to be, right? Oh no, this is actually the iterator one. This is the fold and counting it up. But that's not what's gonna actually run here, I believe. That was cool though, that I could at least click through and see a implementation of count. And then yeah, part 2 is actually even easier. We just had one race instead of a lot, and since we didn't have to do any optimization, part 2 just kind of fell out from our part 1 answer. So that was nice and easy, and with that, I think I'm gonna wrap up for the day. Nothing else left to do for this one, so I will be back tomorrow for day 7 of Advent of Code. And in the meantime, I will see everyone around the internet. Thanks. Bye.